Well, що у мене зі звуком? Прийом. Що у мене зі звуком? Прийом. Що у мене зі звуком? Ніби чутно. Окей. Ну що, продовжуємо те, де ви зупинилися вчора. Трохи, може, годинку, півтори-дві знову посидимо над цим ділом. Потім я подивлюся, що там буде з. Ну, коротше, трошки ще в Warframe сьогодні погамаю. А потім пізніше, after Warframe, maybe in the evening or a little bit earlier, I will start another stream where we are purely Unreal Engine 5 focused, and we are learning about input, how input action, how enhanced input work. We continue in this, but for now, let's go back where we stopped yesterday, and well, we stopped in three different articles, lessons. The first is about build configuration. It is how do we configure our compiler, and not only compiler, but the build in general, just so are we building using all the possible optimizations or not. For example, this a build configuration, like the higher level of abstraction of our settings for the build. How do we actually do this? So um, as we want to either make a debug configuration, this is like a dev configuration during development, or we want to make a release configuration. We choose the way we do it in our IDE, and as I am using, as I'm mostly using the CLI, right? I'm mostly using the CLI console interface. I will look up some flags I should put in my commands, just so it builds one way or another. So as we can see, there are different things like GGDB and O2 DNEB. No, I don't know how to read this yet. So these options we are using to choose the way we are building, to choose the level of optimization our compiler is going to do, and therefore how long it is going to be compiling our files. For GCC and Clang users, add GGDB to the command line for debug builds and O2 DNDB bug for release builds. Use the debug build options for now. For GCC and Clang, the O решетка option is used to control this one. Is used to control optimization settings. The most common options are as follows. When we put it 0O, this is the default setting. It means that it completely disables any optimization for the purpose of speed, right? Compilation speed. 0.2 is the recommended optimization level of release builds. This is what we put here when we are doing release build. And 0.3 is some also upper level of optimization, but it depends whether the optimization done with O3 is going to benefit or not to our program. So generally it is only recommended to use O2 and O3 just when you're knowing what you're doing and why. Like this. So uh, once your program is written, you can try compiling your release build with O3 instead of O2 and measure to see which is faster. Well, okay, so we can probably figure out. This is just not as important. We know that there are flags that control optimization settings, and we shall find out what these flags actually mean a little bit, and also what these flags mean. So when we use GCC or G++, if you're compiling CPP, uh, we call object the name of the program and the CPP file like this. And we also know uh, that we can put this kind of flag. I like the other way around. I like to firstly specify the CPP files and then specify things like object file, maybe object even in as the last flag. So CPP file, then ggdb, and we want to see what is going to be. So I can't use man here, right, to figure out what is ggdb. Uh, so we are going to just Google it a little bit. There are three different file we're using. What the difference between G option? G produces debugging information in the OS1 as native format. GDB produces debugging information specifically intended for GDB. And GDB3 produce extra debugging information, for example, including macro definitions without specifying the level defaults to GDB2. So we are going to actually benefit from this flag after we start using GDB. Because when compiling with this flag, we are producing some debugging information. Mhm. And this debugging information, where is it? Uh, where is it stored? Like in object files, I guess. In metadata inside the object files, something like this, I guess. It is possible, of course, that the GDB can produce debugging information that can confuse other debuggers if you're not using GDB. I only use GDB, so I can confirm. So if you use GDB, use GDB, same as GDB2 or GDB1 to help reduce the debug footprint, or 3. If you do not use GDB, use just G, and keep in mind the GDB works with the OS native format too. So G is some analogous flag for GDB, GDB3, just for non-GDB debugger, right? Uh, okay, so this is some information we put uh, in order to being able to use GDB properly, right? Okay, let's flag definitions, something like this. Create this. There are some folder. Name it like GCC flag definitions, and add here our first flag called, which adds a GDB. Uh, GGDB, a flag a flag for GCC compiler and GDB debugger. It gives um, it puts some extra debugging metadata in the object files, which helps, which somehow helps the debugger mm, GDDB1 slash GDDB3 uh, are basically the same thing. With minor differences. And G is also the same thing, but not exactly for the GDB debugger, which is part of GNU project, like this. Usage use case for debugging. For debugging, uh, for debug configuration build / build during development. Okay, let's continue. The other thing we get is the O. So let's we get O and like this. Definition. Mm, Options that control optimization. So uh, uh, in use cases we put oh, so what is this? What have I done? What is this? I pressed some button. Okay, let's just like recreate this file. To set the level of build optimizations. To set uh, the release / production build configuration. Do I need to know more about it? So the O0 level is no optimizations during build at all. The 0.2 are some optimizations, are core optimizations enabled in compiler. Oh, there is O1. Are some core optimizations enabled. The O2 enabling most of the needed optimizations for production build. The O3 enabling some specific optimizations that uh, might even not help, that might not be applicable in all cases. Well, this is it. I don't need to know more. Um, this is a better word, beneficial. So, okay. We know what is GDB, what is O, then uh, there was some other D and debug flag we shall use uh, when setting our build configuration. D and debug like this. Yes. So the use case is set release production build configuration, and the definition is mm, what is D&D bug flag? Where's the definition? I don't get it. What does it do? And is it must to have this release flags? It turns off standard assert. Якісь asserty. Without it, the asserts will stay there. Yes. Oops, that's bad. I never noticed that. What is asserts? I don't get it. I get it. There is some C++ specific thing like asserting, yes, like using assert. And assert is some, as far as I remember, this is a way to uh, prove like that something is true, and if it is not true, the program just shuts down. It exits like this. So using this flag ignores all asserts, right? Standard asserts, which are no, which are part of the C++ standard, which compiler understands right away. So to set the release production build configuration, to disable all possible, я бы так сказал, to remove all standard assertions, they're not needed, just to remove all standard assertions used from C++ code during compilation, like this. Mm-hmm. Okay, and we shall use it like this, like in uppercase. Okay, this is understandable. So we just remove assertions by debug, and we do optimizations by O2, and this is it. Okay, this is it. Well, let's try it out, I guess. What if I don't specify object file to be linked? Is it going to generate me the object file? Let's try it out. I'll put these flags we learned in order to generate the release build to do all the necessary uh, optimizations. Well, it definitely has done something, but I don't get what has been done. What haven't I deleted the AXA? Ah, so it just generates me the exe file named A. Okay, like this. Okay, so this is it. And when we use GGDB, it is going to do the same thing, uh, just in debug mode. Okay, let's go. Let's go to the next one. Uh, I have already passed this one as well. So, in short, what this lesson is all about is that our compiler, nonetheless, what compiler we are using, may have its own changes of how he understands the C++ standard, and not only changes but also extensions. So, uh, how exactly he is going to understand the standard, uh, and also these compiler specific behaviors are called compiler extensions, because, for example, some some errors which may be considered errors in strict ISO C++ standard may be not considered errors when compiling via some compiler, and it may even produce some exe file, right? Um So if you want to be sure that we have no errors or no warnings, like which may result in some errors in future, we just want to be careful and sure in our code. Uh, just it fulfills the standard. We use things to disable these compiler-specific omitments or compiler-specific behavior, just for it to be strictly following the standard and not omit some, not permit omit some uh, things that might break our code in some way. So you can disable compiler extensions by adding the pedantic errors flag to the compile command line, because I'm using this one. Well, so we just add another flag. We call it pedantic errors txt. Uh, to disable the compiler specific extensions. To consider um, all the compiler specific extensions, to consider the uh, to consider all of the compiler warnings as ISO C++ standard errors when compiling, like this. And the definition, like there are a lot of such flags which may enable some things and disable some things, not only pedantic, right? So the is++ standard, like which compiler considers not a big deal, uh, like the ISO standard may consider a big deal. So when we are going to write a clean code, like clean compiler agnostic code, uh, then we shall be writing the standard code and mm, consider every warning as an error. This is a good practice. Like we may disable this in some cases, I don't know, but no, we of course we are going to disable this because of course we are going to be facing a lot of code which is which has a lot of warnings, like not five, not 10, not 100, maybe even thousands of warnings. And this is not a good thing. Like, we can solve these warnings in some way, but we shall not focus on solving these warnings. We shall be focused on preventing them. Right. So um, when we are writing from scratch, we shall be focused on preventing these warnings. So when I am going to write my learning atomic programs, I'm going to use these things in order to get this feeling of no errors, of no warnings, to figure out where can the warning possibly be, what are the problems that can possibly occur. So I shall probably enable these things. Uh, at least enable the pedantic errors to strictly follow the standard. And then maybe look at some of these extra flags, like, which I might be using. I have another. I have even. I have even the useful GCC flags right there. Warnings for safety, wall, all possible warnings, uh, more warnings, uh, even more warnings, sign conversion, special warning case with signs, uh, make warnings compilation little error, then versioning, uh, and template compiling command, as I stated here, is like this. Okay, so we figure out what shall we use to configure the build configuration. We figure out what is pedantic errors and what is used for. It is used to strictly follow the C++ standard in some cases, and and to disable the compiler, to make all the compiler warnings which omit the standard as errors. But not, I think not all warnings we get from compiler are warnings based on the standard omitments. So I shall probably write this a little bit like this: to consider all ISO C++ standard errors to be errors instead of to be actual, to be fatal. I shall write to be fatal instead of simple warnings when compiling. I think that not all warnings we are getting are warnings based of the standard omitment. I think. Hmm. I probably sure that there are behaviors in standard that that are generally allowed but not recommended, and such errors may be allowed in the standard but not considered a good practice, right? So so um, so this pedantic errors flag is not making all possible warnings the errors. It's just making the subset of these warnings which correlate with the standard, the fatal errors, like this. Okay, okay, we are not going to be mm, reading these ones for now, I think. What we are going to do is Well, we are going to use pedantic errors, I think. I think we do in all cases. For VS Code users open the task.json file. What if I just use pedantic errors in my file right now? Are there any problems? I hope no. Wait. What if I remove this line from the code? Nothing. What if I do like this? I don't get any warnings. Hmm. Pedantic errors. How do I get an error using this thing? How do I actually get an error? Mm. How do I cause an error in my code which will break pedantic errors? Give an error whenever the base standard requires a diagnostic in some cases where the is equivalent to pedantic, the latter option is unlikely to be useful as it only makes errors with diagnostic that are controlled by pedantic. If you want to be, if you want the required diagnostic that are warnings by, uh, the required diagnostics that are warnings by default to be errors instead, but don't also want to enable the pedantic diagnostic, you can specify pedantic errors. Pedantic, pedantic errors to enable them, but only as warnings. Some required diagnostics are. What if I make some kind of error? Is it going to show me even? Yes, it is going to show me. Some required diagnostics are default, some diagnostics. How do I test this thing? I want to test it. How do I test pedantic errors flag? Okay. So there are a lot more flags as I thought. And the whole purpose of this one is to consider standard aviations as warnings. But I guess this not considers like this one standard warning. Or maybe the problem is I shall configure my compiler to analyze it like in the VS Studio, in the VS Code. Hmm. Yeah, I mean that's JSON file which we've been using previously. So VS Code does not automatically add a new line to the end of code files that are missing it. Something that is pedantically required by the standard. Fortunately, we can tell VS Code to do so. Open VS Code and go File, enter insert final line. So if I purposely uh, go and do it like this, no, we are going to do it another way. We are going to go to the preferences, disable this new line, insert a final line at the end of the file when saving it. We are going to disable it for now. We are going to remove this line and use and compile, try to compile. As we can see, we don't see any problems here. The problems are not appearing. So as a developer, you may forget that you're, well, you can't, I would like to see this problem in the warning problems. So I would like to see this problem right here when I'm enabling some flag, like precompile, precompiling in precompile time. I want to see it before I compile. But as we can see, if I just use this thing right now, it is going to break, right? It is going to break. Oh no. Or isn't going to break? Hmm. Maybe I shall. Recognize command line options. So it actually recognizes what I am writing. Uh, Pedantic errors. I just want to get an error. I want to be shown a warning or an error or anything. Well, mm, maybe we should ask this in ChatGPT. I have the following program in C++. Know that there's no new line in that. I want to test out the pedantic errors flag for G++ compiler, but the problem is I don't know how to easily do it. Mm-hmm. Certain versions of G++ pedantic errors flag do not consider the new line as an error. Uh-huh. Uh-huh. Okay, so the compiler just just does not consider this an error, and it is normal because it is not considered a full error in standard as well. So okay. So okay, as far as I'm concerned, since at least 2017, the compiler is not like such pedantic to such extent. Okay, can you please provide me with the most basic example of not the new line one when the pedantic errors flag will actually show error. Using a non-standard feature, register keyword. Register keyword is considered deprecated and removed in C++ 17. If you compile a program using pedantic errors, C++ will generate an error if you try to use it in code. Mhm. So let's try it out. Um, pedantic errors violated. .cpp. Like this. And now we are going to compile it with pedantic errors. And as we can see, we are not seeing this problem beforehand. We will see it just after we are compiled. So I would like to also see it, like to analyze this file during the pre-compilation time, during the development time, I'd say. We are going to configure this in a moment. Plus pedantic errors. So pedantic errors violated. Uh-huh. Well, actually, does not follow register storage class specifier. So yes, this is it. This is it. This is it. Uh, well, um, can I get this kind of warnings slash errors beforehand in my IDE during pre-compilation, not after I use GCC? Yes, you can get this kind of warnings and errors before compilation. Uh, most modern IDE or even lightweight editors like Code with proper configuration support real-time linting, static analysis, and pre-compilation checks. These tools can help catch issues like deprecated keywords, blah blah blah. Here's a few ways to achieve clang tidy in VS Code. This is not what we need. CPP check, not what we need. This is some extension in VS Code. CPP check. C-Lion, Visual Studio, using compiler warnings in IDE. If you want to make sure that you're getting G++ specific warnings like pedantic errors directly in your IDE, you can configure your IDE to run G++ with specific flags. Install the build system or build plugin. This is this is this is the plugin C++ that we had, right? With pedantic errors flag, configure the build process to run G++ with the desired flags, which will then show errors and warnings as you compile from within the IDE. Okay, so in order to see these errors beforehand, before compilation, we shall find a way to configure our projects beforehand. And as it was done right here as it was done was it done right here? I guess. What we had is this thing, uh, VS Code, right? VS Code, CPP properties, then settings, then tasks. I guess tasks is what we need because tasks is about compilation. So we have one task, the CPP build type of label. This is just a command C++ exe. Argo args. This is args which they put when we try to build via this button or via F7. So the G1 is right here. So this is the development build. Uh, Object just to say that we want to just to specify uh, the target file dir name and file base no extension name with exe. No, specify the exe name and the location. Options, uh, problem matcher GCC. Problem matcher to use can easily be a string of a problem matcher definition or an array of strings. So if we add here after exe or before exe, right? If you add things like pedantic errors, mm, things like pedantic errors, is it going to pre-analyze each of our files or not, and show the problems in the problem setting? For example, if we take this code and create a file here, pedantic errors violated, and do it like this, will it find this? Will it find the violated problem and show me this problem beforehand? Mm-hmm. Show errors. So it is showing the error after compilation, like has been started, but not beforehand. After we've compiled this file, it actually shows the problem, as well as when we do it like through through the CLI purely. It just shows us that arrow is right here, but not in the problem section of our IDE. Mm-hmm. So it actually shows the error in the console, but it does not show error in problems because we haven't configured our VS Code to work with GCC. We just open the terminal and use pure terminal. I want to both use terminal and see problems right here, if it is possible. And as we can see, the problem is right here still. It even shows us that what the problem is all about. Our standard of 2017 does not allow the register storage class specifier. So, So if I if I do it like this, right? No, not like this, but rather just like this. The problem does not go away for some reason. What is this all about? Surely after we do it like this, everything is gonna be okay. It has compiled. There's no problem whatsoever anymore. It still considers it a problem. Maybe because I have used the CLI and not rebuilt right here. Yes, after rebuild through VS Code, it understands that mm, it understands that there's no problem. So it understands only during compilation time, not beforehand. This is my problem. I would like it to show me the problem beforehand, before I even start the GCC. Is it possible? Show warnings. Uh, so show GCC warnings before compilation. Is this even such an important thing to do? Uh, I just don't get it. So if you do some kind of work, right? We are writing them 50, 60, 70, 80, 100 of lines of code, like and we don't see any problem, any warning at all in this section before we use the compilation one. This is just not good. How to enable GCC warnings in VS Code? I would mm, enable GCC warning in VS Code. How to turn on all warnings in GCC while using VS Code. Recently, I came across a problem written in C where there was some undefined behavior due to which there was some segmentation error, while other people who helped me debugging it were getting warnings from their compiler, which was GCC2. In my case, while running that same problem in VS Code, it gives no warnings and not even a single error, and sadly no output. The execution uh, starts and then closes on its own in the terminal. I want these kinds of warnings. Uh, there's no option to turn all of the warnings in GC, contrary to exception wall and behavior. You should try adding wall extra wall when you compile. Those options tell compiler to be more strict. I don't understand. Can I see errors? Can I see in pre-compile time or no? Before the compilation. So I'm just writing code, and right away I see the error of no, of the code I write. Is there such a possibility? Maybe I shall configure the IntelliSense somehow. Problem matcher. The problem matcher value selects the output parser to use for finding errors and warnings in the compiler output. So, mm, parser to use for finding errors and warnings in the compiler output. In the compiler output, то есть подразумевается, что все-таки компайлер у нас компайлит. For GCC, you'll get the best results. Okay. To build multiple files in your task.json, you must explicitly list the files. Use a build system like make or cmake, or implement the following workarounds. Значит, с 3 ноября MSys 2, то, чем я пользуюсь, disabled wildcard support for MinGW64 by default. UCRT. Using a build system like make or cmake. Maybe this is what I need actually. Or implement the following workarounds. What is this all about? Do I have the logins? No, I don't have. I started learning C++ and I very used to VS Code, so I configured VS Code for Microsoft C++ using this guide, configuring MSVC. This is what I have been doing, right? A little bit. I also tried setting it up, using GCC and MinGW. It works perfectly fine, but neither of them give proper warnings. I tried using Visual Studio recently, and it gives me a lot of more warnings about little things like warning C40118, sign mismatch. When I compare two such numbers, or a warning about declaring an int and assigning it a decimal value, I know it's not that big an issue, but I would really appreciate if someone has a solution to this problem. The gcc command line is in the task.json file. Try adding wall to the R section of that file to enable all warnings. I wanted to use the Microsoft compiler, and similar to this, putting vegetarian in the arc section gave me what I gave me what I wanted. I wouldn't have found that without the guidance. So they say that we can just go in tasks JSON and like at the wall setting like this. I don't understand. What? Current version of VS Code somehow does not show any warnings of C++ code when typing the code. For example, using the same photo from above question, basically int foo 132 should give me a warning. Errors uh, can show, but warnings don't. The command suggests using C++ clan command adapter, but I don't know what it is. Is there any way to let warnings show up? Thanks. Added my CPP my C CPP properties JSON. This is the file which we use for the for the CPP extension in the VS Code, right? Mm, well, it is logical because tasks is the configuration of compiler. So we probably don't get this behavior from config of our compiler, right? Because compiler cannot precompile our file in VS Code and integrate with VS Code. It is logical. Settings is also probably not what we are looking for. So the only thing we are looking for, therefore, is this file, which configures the extension of VS Code. So probably this is the way to see problems beforehand, right? During writing. It even it even allows me to write int x equals 10.2. You see? No error at all. It allows me to write register. It doesn't seem to show any warnings or problems despite despite having the pedantic errors right here. Um, but when we go in the run section right here for this file, then we are going to see two problems. The first is the register word. Right, we're still going to see it because we compiled, and after we compiled, uh, because of this file, which said that we have pedantic errors, it still shows the problem, and it does not know that we have removed this problem. It will know just after another try. Like after another try, it still sees the problem. No, it does not see this kind of problem because I think this is standard. This is okay by the standard, right? But it is not okay um, by human means. So I want it to show me both problems. I want to show me both this and this. Uh, and I want to show it before I even click the build button, like this, before I even click it. So as we can see, the way we can achieve this behavior uh, is by configuring the CPP properties file, right? What we see here, let's compare. Um, Configuration identifier command suggests using clan command adapter, but I don't know how. Name in tree. Name is not important. Include path. Workspace folder slash everything which is inside this folder. Workspace folder is a folder we are right now, right? So a code C++ slash everything inside this one. So everything there. Include path is a list of paths of the IntelliSense engine to use while searching for included headers. Searching on this path is not recursive, specified to indicate recursive search or not recursive search. For example, workspace folder will search through all subdirectories while subfolder will not. Usually this should not include system includes. Well, this is not important. Then defines list of preprocessor definitions for the IntelliSense preprocessor definitions of IntelliSense engine to use while parsing files. Optional use equal to set value. Debug Unicode. Compiler pass. C standard, CPP standard. Then IntelliSense mod default. Windows GCC x64. Absolute manufacturer of MSVC, GCC or Clank. Outside of set to default, extension will choose the default for that platform. Or compiler args. This is it? I guess this is it. So we are just compiler arguments to modify the includes or defines used Arguments that take additional space delimited arguments should be entered space arguments. So a command's full path or list of full paths to compile. Okay, we choose args and put here the, for example, the pedantic errors, right? The version is 4. Well, let's also put wall thing. Sorry. Hmm. Anything is Nothing is happening for some reason. How to install Clank, which is required by the extension. Is Clank required by this extension? Completion for diagnostic using Clank command. But we don't need the Clank. Clank is another thing. It is not GCC. I'm a little bit confused right now. Is it possible to tweak VS Code somehow to see GCC warnings in the text? Where have I been watching beforehand? Like this? Ah, this is the similar question. Refer to the screenshot below. It shows only errors in the console. Tried adding wall compiler flag to args in task.json, but it didn't help. But he wants to see these errors and these warnings in the text editor, not after built in console. And I also want. Below are my settings: editor font size, after save. What does this information give us? Okay. The warning and errors are shown in problem panel. You can see problems for on it, but this is our after compilation. How doesn't it understand? You might need to install Visual Studio Intelligent Code or C++ IntelliSense to help you identify mistakes before compilation. Well, I checked my extensions and I found out that I'm also using C++ Clang command adapter. You can try that also if you want. I hope that it will work for you. Hmm. As Houston, you have to add Houston. What Houston? Use the conversion flag for GCC to have truncate warning. You have to add it to task.json in args. What is the conversion? I don't understand. What conversion? Warn for implicit conversions that may alter value. I don't really get it. As Houston, you have to add the conversion flag to the GCC args. Your code should be this. IntelliSense mod default, compiler args volk on the conversion. Mm, This I did this for my task zone, and this works as you can see. I don't get it. He's asking specific problem why his version of VS Code doesn't show any warnings when typing the code. For example, using the same photo from above question, basically int foo1.22 should give me a warning. Arrows can show, but warnings don't. Mm, so, but I also have register int, and this is pedantic error, not conversion error. And I have put the pedantic errors right here, and I have put it right here, but nothing happens. So I'm a little bit confused. Conversion is not what I need. Maybe the pedantic is changed, but no, it is not changed. Mm, How do I actually get these arrows in here? What is C++ IntelliSense? C++ IntelliSense. This is it. This is what I have already. Hmm. This was before. Now it is deprecated. Hmm. Now it is deprecated. So I can't believe that I can't solve this such an easy problem. Um, Visual Studio and Telecode. What is Visual Studio in Telecode? Mm, CPP check is another extension? Uh-huh. Mm. How do I make this work? Maybe I shall find some video, some great video about how to set C++ for VS Code. Well, I'll try to figure out it myself, and when I'm done figuring it out, I will uh and also done playing Warframe, I will continue. And probably we shall I'll figure it out myself. and then we come back and we switch to something else. We switch to Unreal for now. So what we have done, we have learned some of these flags, and I got stuck on in how to show the problems right away, how to get errors when I see something like this during the something like this during the editing time, the pre-compilation time, not the compilation time. I probably will also delete this stream. Okay, so this is it. Maybe I won't delete.